Hey guys, how are you doing? It's Professor Wiggins here. Today we're going to be talking about stellar populations inside of the Milky Way galaxy. So our story today begins with a guy whose name was Walter Baade, who was doing research at the Mount Wilson Observatory in 1944. Walter Baade was looking at the inner regions of nearby spiral galaxies, what we would now call today the nuclear bulge. And we can make this seem a little bit complicated, but it really was just him looking at the centers of these spiral galaxies and realizing they had a different color than the blue arms of the galaxy. I wonder if there's a difference between those two types of stars. So just imagine, if you lived during World War II, you could have made great contributions to science by just noting that the nucleus of a galaxy has a different color, orangish, reddish, than the arms of a galaxy, which are bluish in comparison. Actually, it's not that simple because we would probably have been drafted to the front lines during World War II, and instead of contributing to science, we would have just been fighting for our lives. But those are minor notes, of course. The stars in the center of the galaxy had light that was dominated by red supergiants, whereas the stars that were in the disk of the galaxy had light that was dominated by blue supergiants. So he decided to break stars up into two major populations. So he called population 1 stars the stars that appear in the disk. These are the ones that appear bluish in a galaxy from a distance, even though there's all types of colors of stars in the disk of the galaxy. Most of the light's coming from these big blue supergiants, which are so bright that their light just dominates everything. And they tend to live in dusty environments and gassy environments, which is what we picture when we think of the disk of a galaxy. He classified population 2 stars as stars that are much like the stars in the bulge of a galaxy, or say an elliptical galaxy, or stars in a globular cluster, or just stars that are floating in the halo. These are stars whose light is dominated by red supergiants. And they tend to live in gas-free environments. So if you look at, say, the central bulge of a galaxy or, say, an elliptical galaxy, you don't see those dramatic, dark, dusty, gassy bands that you see, say, in a spiral galaxy. So that's all good and well. He has two populations of stars now. Some stars that are living in the disks whose light is dominated by this bluish light from these blue supergiants. And then you have stars that live in, say, the bulge of a galaxy or out in the halo of a galaxy whose light's dominated by this red light. It wasn't until like 1965, that's about like 20 years later, that people began to realize that there may be more to this classification than Walter Baade had originally realized. In particular, they began to realize that the two populations were different in age. So when people began to put stars on HR diagrams and they plotted all the stars from the bulge and compared those with plots that contained stars only from the disks of galaxies, they recognized that one population was much older than the other population. So the stars in the bulge of a galaxy and the halos of galaxies and in globular clusters are actually much older than the stars in the disk of a galaxy. In a way, that kind of makes sense because star formation is still taking place in the disk of the galaxy. The sun is relatively young compared to all stars in the universe. It's only 4.5 billion years old or so. Whereas if you look in, say, the nuclear bulge of the Milky Way galaxy, some of those stars are 10 billion years old, almost double that age. But the differences between these two populations actually goes even further, and it kind of begins to give us a clue about how maybe the Milky Way galaxy was actually formed. People began to take spectra of stars that were in the disk of a galaxy and began to realize that they had a lot more heavy elements in them than stars in the bulge of the galaxy. So this paints overall this kind of interesting picture of what the Milky Way galaxy is. If population 2 stars are on the inside in the bulge and in globular clusters and in the halos, it tells us that those are the parts of the galaxies that actually formed first. The disk of the galaxy, which contains these stars with heavier elements, would have formed later on. And indeed, star formation is actually taking place inside of the disk of the galaxy today. So what this all seems to suggest is that there's a relationship between, say, population 2 stars and population 1 stars. Stars are these thermonuclear factories. They make heavier elements. So they turn hydrogen and helium into things like carbon and oxygen and everything on the periodic table that's actually higher than hydrogen and helium. And so the longer stars are in the universe and the more they spread their elements through space through their spectacular deaths, the materials from which the next generation of stars is going to be even more enriched with these heavier elements. So this is kind of captured dramatically in simulation. Over here is a visualization of a simulation in which we're actually trying to picture how stars distribute their heavy elements into space, and it's a spectacular and violent process. If there's star formation that's taking place inside of the neighborhood of one of these explosions, you can bet that those new stars are going to contain some of these heavier elements. So older stars have fewer heavy elements because the ashes from which they were born weren't as enriched with heavy elements as, say, stars that were born very recently. This leads us to ask the question if there's such thing, by the way, as a population 3 star, which would be a star that was only born from hydrogen and helium, no heavy elements. What was the first generation of stars? What did that look like? And that's actually an active search that's going on right now, and telescopes like the James Webb Space Telescope will be looking at the first galaxies and seeing if we can actually spot structures which are only composed of hydrogen and helium. These would have been really interesting stars, by the way. They would have been hundreds of times the mass of the sun, tens of millions of times more luminous. They would have been different creatures than the stars that we see in the universe today. So the major points of this video are this. We've divided all of stars into two types, population 1 and population 2. Population 1 stars are the stars in the disk. They're like the stars in the sun. They have relatively high numbers of heavy elements in them. All stars are mostly hydrogen and helium, but of all the stars in the universe, these stars have the most heavy elements. We have population 2 stars, and these are the stars that occupy the halo, the bulge and globular clusters, and even the thick disk of the galaxy. They're older stars. They don't have as many heavy elements in them. Stars are big thermonuclear factories of heavy elements, so the longer the universe is around, the more and more heavy elements will be in the universe, and the more enriched each generation of stars is going to be with heavy elements. That's it for today. Next time we'll talk about the formation of the Milky Way galaxy, so see you then.